So in your orange packet, we are looking right here at examples 12 and 13. And example 12 says, Ryan has a $16 gift card for a health store where a smoothie costs $2.50 with tax. What are the possible numbers of smoothies that Ryan can buy? Let S represent the number of smoothies that Ryan can buy. Like I was saying, some of these don't have like the phrases that we're used to seeing, like the less than or at least or stuff like that. So what we have to do is just kind of reason it out. So see right here where it says he has a $16 gift card? Would he be able to spend more than that amount or less than that amount? Less than, right? Like he's not going to be able to spend over $16 if that's all that he's got. So I'm going to put less than or equal to $16. And then I can also see that the smoothie costs $2.50 with tax, and it wants to know how many he can buy. So basically what it's asking is how many times 250 goes into 16. So to figure that out, I'm going to do 250, so like $2.50 per smoothie. So now I need to solve that. How do I solve that inequality? Yeah, divide by 250 on each side. So S is less than or equal to, what is that? 6.4? Okay. So if S is less than or equal to 6.4, like what does that mean in terms for what Ryan's doing up here? Okay. So, and remember, we have to make graphs, and on the graphs of these, we have to ask ourselves about decimals and negatives. So can he buy, do what? Yeah, I mean, it is, like, you know, I could buy a smoothie and we could split it and then we each have half, but I don't think when you go to buy the smoothies that you can say, like, I want 4/10 of a smoothie. Like, that just doesn't work out. So I think probably here we can only have whole numbers. And what about negatives? No, no negatives. So for my graph, I should put what is my smallest number? 0. And then what should I put as my biggest number? 6. And then I only want the whole numbers in the middle. So I'm going to do 1, 2, 3, 4, and 5. And then put dots to show that I only can buy a whole number of smoothies there. No, sir. Dots is for whole numbers. And then on example 13, it says a pitcher holds 128 ounces of juice. What are the possible numbers of 10-ounce servings that one pitcher can fill? Let n equal the number of servings that the pitcher can fill. So what do y'all think about this one? Is it going to be less than, greater than? Kind of tricky. Less than, okay. Less than or equal to 128, because you can do less than 128, but you can't do more than 128. Okay, and you've got 10-ounce servings, so how would you set that up? Because it's 10 ounces per number of servings. So to solve, divide by 10. So n is less than or equal to 12.8. So when I make my graph, it's a word problem, so I got to think about decimals and negatives. So can I have like a decimal part of a serving? I think you could. I mean, I think it's difficult because on this last one, we said, okay, no, you can't have part of a smoothie. But on this one, like, I think if I'm at my house and I run out of juice, I could just, like, pour the rest of it out, and that's, like, a fractional part of it. So I think you could have decimals here. But I don't think that you could have negatives because you can't pour negative juice. So I'm going to stop my graph here at 0. Okay, so I'm going to do 0 to 12.8. So I'm going to do closed circles. And then I'm going to shade in between because decimals would be okay. All right, so that's it. So the homework for tonight is going to be on page 183 for the most part. The one that it says for page 211, like if you're following along on your calendar, don't do that one. But this other one that's on page S30, I wanted to point out that this little thing right there is an S. It's not a 5. It's not page 530, it's page S30. So there's like a little green section in the back of your textbook, which is where page S30 is located. Okay, nope.
Where is S30 located?
In the very back of your textbook.